Hi, friends. Welcome to this lecture series on ECE Made Easy. The lecture series mainly aims at the student community who are interested in having the basic concept first and then getting into more details through mathematical understanding. So, this lecture series aims at making the foundations strong, making the basics clear about the various aspects of electronics and communication engineering. And in this, we have divided our lecture series into various parts. In the first section, we look into the basic elements, wherein we look at the various components used in building a circuit. That can be a resistor, inductor, and capacitor, and the different materials which are made available for working on the electronic side, maybe a conductor, maybe insulator, or a semiconductor. And once we are through the semiconductor, we know we need to design, build devices which help us in taking up next models. So here we study the working and building of basic devices like a two-layer device called the diodes and a three-layer device called the transistors. So there are many types of diodes. We look into detail when we are through it, and there are many types of transistors. We get into them. Most commonly used transistors are the bipolar junction transistor and the field effect transistor and their variants. Once we are clear with all the components, the material, and the devices available, then we can start building the basic circuits. In the basic circuits, we look in first converting power. We have power in two forms, one in the battery and one from the AC source from the transmission system. So battery provides us a direct current which is called DC, and the power source provides us AC, alternating current. Alternating current happens to be cheaper, and the direct current, that's a batteries, happens to be a bit costlier, and reusability is another problem. Once the battery is dead, it has to be thrown out, and it's going to be costly affair. So in this regard, a circuit specialized for converting alternating current into a direct current is built, in which we call a rectifier. In some cases, when alternating current is not available, but we need to use alternating current only, and if direct current is available, then we need another circuit which converts direct current to alternating current, which we call an inverter. So, in this section, we just look at the foundation, how AC converted to DC and how DC converted to AC and all. Once we have AC uh, as against electrical circuit, AC in electrical circuit deals only with a fixed frequency. It may be a 50 hertz frequency in India or 60 hertz frequency in US. But the electronics and communication engineering deals with a wide spectrum of uh, alternating current, and there sometimes we need to work with a particular part of the spectrum. A band of frequencies are required. So when you want to choose from the whole spectrum of a particular band of frequencies, then we have a specialized circuit which are called filters. We have basically four types of filters: low pass filter, which allows low frequencies to pass through; high pass filter, which allows high frequencies to pass through. We have band pass and band elimination. And the name tell what they do. So we just look in detail what they are, how they work, and where they can be used. and all in a qualitative way, and everywhere uh, ensure that day-to-day life activities or day-to-day examples will be used to make the concepts clear with minimum mathematics used. And once we have the signals available of our required frequencies and all, it may be required to increase its strength. So for doing that, we need an amplifier. And these amplifiers may be of two types, small signal and power. And we need to look at the behavior of each small signal or a power is different. So we need to see what each one deals with, and how they behave, and how they are working, and what are their basic concepts. All these things we look at with our again the analogous systems, which are very much familiar to our day-to-day activities. Then comes specialized circuits which create the signals we wanted. So we want oscillations to be produced as per our requirement. Whenever we want, we need the oscillations to be created. So for that, we come out with a specialized circuit which we call an oscillator. Oscillator is a special circuit which converts DC to AC, as against the one which we talked in the beginning, an inverter. There, the power conversion DC to AC is for a particular 50 hertz or 60 hertz, whereas these oscillators provide any frequency of your interest. Once we are through with the basic circuit, we are now into bigger domain. We get into building bigger circuits. Let me call them an integrated circuit. In this integrated circuits may be working with analog systems, like wherein a time domain is continuous and the magnitude is also continuous. And in this specialized circuits we look into, and which will be helpful in thinking bigger developments, and making bigger things to come up. Once analog part is over, then we get into digital part. So the various digital circuitry we have, and how they are built, how they are work, what they are meant for, we just look into them more qualitatively, nothing quantitative. Then comes some specialized things where it involves both analog and digital together, which we call mixed. Then the second part of our course is communication. The course name is Electronics and Communication Engineering. So our the second half is fully dedicated to communication. And once we are through electronics, now let's go into communication side. And here we just look at the various media available for making electronic communication through, and various modes of communication, what way the communication can take up, and then how do you interface the communicating system with the media is what we need to look at. Then comes the most important part of our world, which is a signal. Signal is what we are dealing with, whether it is a communication, whether it is electronic, whatever is being generated, whatever is being received is what we call signal. Commonly, a signal is one which keeps varying with time, and we want to represent this signal in a more abstract way, instead of keeping explaining how the signal looks like, or how signal keeps changing and all that. We need to talk in a more quantitative way, so that the communication or interacting between two persons regarding discussion of a signal can be made easy. A signal of any form can be represented quantitatively using some transforms. So, transforming into some other domain, things become simpler for representation. And most commonly used transformations are the Fourier transform, Laplace transform, and Z transform. Here we just look at these transforms, how they are useful in explaining what a signal is, how signal is, and all. Then coming to system, if you want to explain what the system is, how the system is behaving, the best way is to just switch on the system, give supply to the system, and the moment you give supply to system, just look at what the output is, what the system is behaving like. That means your input is 0 before switching on and remains high after switching on. So the waveform, if you look at it, 0 before t equal to 0 and 1 after t equal to 0 forever. This looks like a step input, and that's what uh, when you just switch on the system, you get some output, and that output can correlate with the signals we got in the previous section. So just try to find what signal you are getting, and then you say that this is the signal you get from the system when step input is applied to the signal system. So this is what we call step response of a system. So just to switch on the system, look at the output, and the output gives some response. Look at the response, compare the form of the response, and give the what you call quantitative form of it, which again can be taken up using Fourier transform or Laplace transform or Z transform. Once we have all these things known, then we need to have specialized processors which can process these things for us. So we don't want everything to be done by us. We want some machine to solve this problem. So we built processors. These processors can be divided into two parts: one a basic processor, one advanced processor. Basic processor is one which we can look at and try to visualize and try to see how the things work, because it's a small one, so you can follow the activity inside and try to understand. And the depending on the requirement, the type of the processor went on growing, and now we have very high advanced processors. So we cannot get into the dip into and try to understand how they behave and all that. Therefore, in the basic version, we just try to see how they work and all that. And once we know how they work, we just try to understand how advanced versions may work. We can just make an analogy and see if this is how it works, then this could be working, and so like that. For making all this work according to our requirement, we need to program these processors, and for programming, we need languages. So, what are the need of programming? What are the various languages we have? That's what we look into our last section. So, one thing, all this, whatever we discussed, are going to be dealt with a minimum mathematical requirement, and most stress is given in making the concepts clear using some day to day concepts, day to day activities. So it makes the foundation more stronger, so that once this lecture series you are through, you will be ready to attend any real time course. You can take up any mathematical study and have no problems at all in understanding the things which are explained in mathematical language. So What are you waiting for? Please do join the course and enjoy the journey, and ensure that you get as much as you can, and be successful in your career. Thank you.